Hi and welcome back to Module 8, our last module before our HSC, and today we're looking at video number 12, testing for anions. So in our last video and in our last lesson, we looked at testing for cations, so the presence of those metal ions there, those positive ions, and today we're looking at testing for anions. So our anions are our negative ions, so our sulfates, our chlorides, our carbonates, and so on. So let's have a look at what that looks like. So we're going to conduct again qualitative tests using flame, precipitation, complexation, and we're going to be looking for the presence in solution of chlorides, bromides, iodides, hydroxides, acetates, carbonates, sulfates, and phosphates. So let's get into it. Like before, and I will just move this. Like before, we are going to look in class at a whole host of different flowcharts for identifying anions in solution and create our own using the knowledge that we have developed through our experiments and also our looking of tables and so on to work out what reactions will work to produce what precipitate and so forth to allow us to make those decisions and informed decisions about what anions might be present in solution. So like our last video, just quickly going through, and again you can find these in your textbooks. On the slide just roughly, again I've got laminated copies that we're going to work through in class. So we can use our precipitation reactions to identify anions. Flame tests don't work, so that one is not going to help us there at all. So we're going to be looking at these. So many of the tests that metal ions use to form precipitates with our anions that we are actually going to use. Some of these are pH dependent, so you'll notice in this one here we have a sample test with red litmus. That'll tell us if it's acidic or if it's not. And there's many tests and combinations of tests that we can actually use to determine which anion is present. But looking first of all, we've got our group 7 or 17, depending on which periodic table you look at, of our halides. So we've got our chlorines, our bromides, and our iodides. So they all form a fairly similar coloured precipitate. One's yellow, one's cream, one's white, so it's pretty hard to distinguish between them with certainty. Chloride, if we react with silver, we're going to get a white precipitate there. If I react our bromide with a silver cation, we're going to get the cream, and silver with the iodide, we're going to get the yellow. So all reacting with the silver, the colour, depending on how good your determination of colour is, that may not be such a useful test. So we are going to react it, say, with a silver nitrate, because nitrates are soluble, and it's not going to really participate then in that solution. So we're going to need to look at those sort of colours and see if we can use those to determine. Our hydroxide forms blue with copper, so if we add some copper, again copper nitrate because it's soluble, or we could use copper sulfate because it also is, it'll form a blue precipitate there. Our acetate, that's like our ethanoic acid will form an acetate, the CH3COO. So if you smell a vinegar type smell, that's because of that acetic acid. So that is one of the tests to detect the presence of that acetate ion. Then we've got our carbonates, and as you would remember, an acid plus a carbonate will produce a salt, carbon dioxide and water, so our presence of bubbling is a fair indication that carbonate is present. So we can add some acid usually straight up, and if we're getting that bubbling, that's going to tell you pretty much that it is a carbonate, and we can look at that test and go, okay, it's a carbonate, it's bubbling. If not, we can move carbonate straight out and move through a whole series of other different tests that we can do. So that's usually the one we do first. Then our sulfate, again, reacts some barium nitrate with it, and barium sulfate is an insoluble solid, so we'll know that barium is present because most If you remember the solubility rules, sulfates are pretty much insoluble, are soluble except for those couple of exceptions. So remember our PMS, Castro Bear, and then we've got our phosphates, which also produce a white precipitate with barium, but they also will perform a complexation reaction with our ammonia ions. So here we've got one on the screen that we can see testing with red litmus. If it stays red, we can add some silver nitrate. If it turns blue, again, we can add some acid. If we get some bubbles, we know it's a carbonate and we're straight out. If we don't get any bubbles, we can continue through with our testing. Having a look at this one again, which I kind of find is a little bit clearer, and I quite like this one. Again, pop our unknown anions up the top. Now you're going to notice here that a lot of these sheets that I'm giving you are not perfect in their construction. They are missing some of those ions. So if you're looking here, this one actually doesn't have the acetate there. It's got the nitrate here that we don't need. It's got sulfur that we don't need. So again, after we've performed our investigation, we're going to get all our flowcharts out, pick them to pieces, work out what's missing in some, what we like about the layout of others, and we're going to construct our own. See you then.